This is problem 6 from the review sheet, which actually references problem 22 from the chapter 8 review. A brother and sister took 2 different standardized tests. All right, so we've got a brother, we've got a sister. He scored 114, okay, so his score was 114 on a test that had a mean of 100 and standard deviation of 18. She scored 85 on a test that had a mean of 72 and standard deviation of 12. Which one had the better score? Well, remember the statistical measurement that we use to compare situations like this is the z-score. So we need to calculate the z-score for each of these data items with respect to their overall mean and standard deviation for their activity. And remember, the way we find the z-score is we take the data item, subtract the mean, and divide by the standard deviation. So for the brother, we would take his score of 114 minus the mean of 100 and divide that by the standard deviation, which was 18. So for the brother, we get a z-score, and remember, z-score is typically expressed to the nearest hundredth. We get a z-score of 0.777, it's a repeating 7, so that would be 0.78. If we do the same thing, the same process to find the z-score for the sister, that'd be 85 minus 72, the data item minus the mean, divided by the standard deviation, in this case 12, and that gives us 1.08. So in this situation, the higher the z-score is better, because the higher the z-score means that the individual data item was greater above the mean, and in this case, the more you were above the mean, the better you did on the activity, because we're talking about test scores. If we were talking about a race, then you would want to be below the mean, is what you would hope, but if you weren't below the mean, you would want to be a lesser amount above the mean. That would mean you had done better. So in this particular case, more is better. The sister did better than the brother on the standardized test that she took.